Find the ratio of the intensities at of the bright fringe, the center of the bright fringe, to the intensity at a point one fourth the distance between the two fringes from the center. One fourth the distance between the two fringes. Actually, one fourth the distance between two successive bright fringes. That is the actual question. So you must change that question. When they ask you like that, it means that the distance between two successive bright fringes. A distance between two fringes means two successive dark or two successive bright. So the distance between two successive bright fringe itself is is lambda, which corresponds to a phase difference of 2 pi. So it's one fourth of the distance between the two bright fringes. So it's 1 by 4th of 2 pi, which will be pi by 2 will be the phase difference which corresponds to it. The phase difference which corresponds to it therefore will be pi by 2. So once I know the phase difference has to be pi by 2, the ratio of the intensity of the bright fringe at its center. Say for example, if you're going to calculate at the center, is I is equal to I1 plus I2 plus 2 root I1 root I2 cos phi, and at the center phi, it will be central maxima where phi is equal to 0. So if I1 is equal to I2 is equal to I, that case it will be 2I plus 2I, correct, which will be 4I. So thus the resultant intensity at the center will be 4I. And now the resultant at a point where it's pi by 2 is I resultant at that point is again I1 plus I2 plus 2 root I1 root I2 cos 90. Cos 90 itself is 0. So this is what you get I1 plus I2, which is 2I. You already know I is equal to I resultant by 4, the first one, the first equation. So then you get 2I resultant, the previous resultant, by 4, which will be half of that intensity. The new intensity at this point will be half of the intensity at no, here it was 4I, here it is 2I. That's enough. You don't have to compare it with the ratio between IR dash and IR, or IR by IR dash is equal to 4I by 2I. So answer is 2:1. Do you have an answer like that? You can mark it. So then let's go to, oh, this is not MCQ. Okay, next question. The next question is, consider the intensities of two sources. One is I, another is 4I. Obtain the intensity at a point where the phase difference is pi by 2. You know, pi is the path phase difference for 2 pi is the phase difference for lambda. Now the phase difference is pi by 2. What is the path difference? Pi and pi get cancelled, and it's lambda by 2, so it will become lambda by 4. The path difference becomes lambda by 4. You want a phase difference for it, you know, for a lambda it's 2 pi. For a phase difference of pi by 2, so the whole point is you need the phase difference to calculate, and it is readily available. You don't have to do the unitary method, because normally they'll give the path difference so that you can convert it into phase difference by writing 2 pi is equal to lambda, corresponds to lambda. What will be the phase difference for this particular lambda by 2 or lambda by 4? But here the phase difference itself has been directly given, so just a question of substituting. And you know, the resultant intensity is root of it's I1 plus I2 plus 2 root I root 4I into cos phi is cos pi by 2, so this will go away. So phi I is I resultant, so I is equal to IR by 5. So that is the obtained intensity at the point. Okay, now next condition is for a pi. For pi they've already given, this will become pi cos pi. So I resultant, this is at that for point A. For section B, I resultant is equal to I plus 4I plus 2 2s are root 4 is 2 2 2s are 4 4 I, and the angle is cos pi. Cos pi itself is minus 1, so 4 pi 4 pi get cancelled. So I resultant happens to be I. In this case, the I don't call it as this is, we named it as IR, so named it as IR dash at the point B. IR dash is equal to I, which itself is 1/5 of the resultant of that position. When it was pi by 2, no, 1/5 of that. Let's go to next. What are they saying? What is the answer that they are saying? For the first one, they're saying I resultant is phi I. So they've just stopped with this, and they've just stopped with I. They're not writing in terms of I resultant, so that's what it is. So you don't have to do it if you just leave it like that. So next is sum number C, where the phase difference is pi by 3. So it's cos pi by 3, and cos 60 itself is 1 by 2. So it is IR double dash, the resultant at that point C is I plus 4I plus 4I cos pi by 3, and cos 60 is 1 by 2, so it will become a 2I, so it will become 7I. And they've left it like that. Normally, what from here they will take what is I is equal to IR by 5. What is this is I, so they'll replace it as IR by 5. Then the 7I, which is 7 into I itself is IR by 5. So IR by 5. They'll write it like this, everything in terms of IR, but which is everything in terms of the first intensity, but they've not asked it like that, so you can leave it like that. Okay, so let's go to third question. The Douglas slit experiment is illuminated by a wavelength of 6000 Armstrong. The slit width is 0.1 centimeter, 10 to the power minus 2 meter apart. The screen and the slit are kept at a distance of 1 meter. Calculate the angular position angular position of the 10th maxima in radians. Angular position, I know only one formula, which is x by capital D. In the interference, it's x by capital D. I hope this is a double slit experiment. Yes, in that case, theta is equal to x by D. If it is diffraction, you all know it's a theta 2's formula, which is 2y by D. It's 2y by D. Diffraction. That is 2 into lambda into capital D by small d, and that will be the fringe width or the central maximus width by capital D. So 2 into lambda into capital D by small d, d and d gets cancelled. 2 lambda by small d is theta 2. If it's for a single slit and it's for diffraction, you should have memorized that. So coming back to theta is equal to x by d. That's what is angular fringe width. Yeah, that's what they call. But what are they asking here? Calculate the angular position of the 10th maxima. 10th maxima in radians, and the separation between the two adjacent minima, which means beta. Separation between two adjacent minimas or two adjacent maximas is nothing but fringe width. Basically, they are asking for fringe width. They are also asking for the angular position of the 10th maxima in radians. They've given the answer. I don't know, or let us see if we are able to get it. Theta is equal to 10th maxima. 10th maxima, what will be x? The distance of the 10th maxima is 10 into lambda into capital D by small d. Maxima's formula is that only. So it's 10 into, so let's substitute and find out that 10 into lambda itself is 6000 into 10 to the power minus 10 into capital D, which is 1 meter, by small d 0.1 into 10 to the power minus 2. So this becomes 100 by 1, so it becomes just 100. That 100 into this is 6 into 10 to the power 5 into 10 to the power minus 10. This goes, minus 2 goes up, will become 10 to the power minus 8. So it will become 6 into 10 to the power minus 3. So that is the position I'm getting for the 10th maxima. That's what we did in the previous sum. I'm doing the same thing here. So 10 into lambda into capital D by small d. So that has to be substituted here. By the capital D is 1. So answer is 0.6 millimeter. We got the answer. So this formula, memorizing this formula is very, very important. Whenever it is angular, it means you can only use this formula in interference, and you can use that formula which is lambda into capital D by small d by capital D. So lambda by small d for the diffraction. 2 times. 2 into lambda by small d for diffraction. Okay, so that's about it. If you have not memorized this, you can't do the sum. So in terms of you got theta, which is 6 into 10 to the power minus 3, which is 6 millimeter. And what are they saying? Which is also 0.006 radians is the answer. Okay, fine. Okay, but what about the separation between the two adjacent minima is nothing but the fringe width. Separation between two adjacent minima is nothing but fringe width. And separation between two adjacent minima, what have I got here is 0.006 radians. So that is the theta that I've got. The separation between two adjacent minima is nothing but fringe width, which is lambda into capital D by small d, where lambda itself is 6000 into 10 to the power minus 10 into capital D itself is 1 by small d itself is 0.1 into 10 to the power minus 2, which is basically the calculation that is here. Can you see the calculation that is here? You had multiplied by a 10, and here you are not going to multiply by a 10. That's only difference. So it will become you multiplied by 10. So here you won't multiply by 10. I'm sure that is the only difference, correct? So won't it become 6 into 10 to the power minus 4? So then would it become supposing I'm writing as 0.6, which means I've multiplied by the 10 to the power minus 1. I should also divide by 10 to the power minus 1, so that this and this makes it 0.6. This becomes 10 to the power minus 3, so 0.6 millimeter. Oh, now it's fine. So that is what it is, because this is normal fringe width. The distance between two minima or maxima is all the same. So can I go to fourth question? So the first question is, ray of light I, intensity I, is incident on a parallel glass slab at a point A. It undergoes a partial reflection and refraction. Yeah, can you see it's been given reflection and refraction? At each reflection, 25% of the incident energy is reflected, which means 75% is getting refracted. The ray AI and BI, where is BI? They're not even given where is BI. Undergoes, I look, oh, there is. Okay, which means the first ray which is coming in is getting partially reflected as A1 and getting refracted. The refracted ray again getting partially reflected, and that getting refracted as B1. Oh shit, okay. Undergoes interference. The ray A1 and B1 is going to undergo. Calculate the ratio of I max to I minimum. I'm gone, I'm telling you. So can you see that the first, for let's take A1 for that matter. Let's original intensity be I. So then therefore its A is going to be is only 25% of the energy. So it's becoming I by 4, A1. Okay, A1's ray will have only I by 4. Let's look at what's happening to B1. B1 is undergoing 75% is now getting refracted, which is 3 by 4 of I is getting refracted as so let me draw this. The first ray which is coming in is getting A1 will be I by 4, which is 25%. Then it's going to this is going to have 3 by 4 of I, which is further going to get undergo reflection, which is only 1 by 4th of this. So 1 by 4 into 3 by 4 of I will be 3 by 16 of I. So 3 by 16 of I is going to undergo reflection, and then 75% of it will get undergo refraction. So 75% is 3 by 4 of 3 by 16 into I, which is 9 by 48 I. So the ratio of that is the emergent ray. Okay, so the ratio of the incident ray, which is I by 4, the ratio of the first reflected ray to the ratio of the last reflected ray, which is 9 by 48, 9I by 48, I and I get cancelled, 48 by 4 into 9, 4, no, 4 ones of 12 by 9, which is 4 by 3. So I did I1 by I2. Why did I cancel it? Yeah, it's cancelled by but the answer is wrong. Let me redo it again. So let me try it again. So you know the result intensity, falling intensity is I, reflected is 75%, so I by 4. For the next ray which is getting refracted, there will be 3 by 4 of I, 75%. That is going to get reflected only 25% of it, which is 1 by 4 of 3 by 4 into I, which is 3 by 16 into I. On that 75% will get refracted. I don't know if I'm considering that correct. That's the part I'm not sure, but I'm just on reflection 25% of incidence is reflected, which means on refraction there will be 75% is what I have to assume. So 75% is again 3 by 4 of 3 by 16 into I, which is 9 by 16 4, so 64 I. Did I write wrongly? Maybe. Okay, so then ratio of this is the emergent light, and so the ratio of this and this is emergent by the final emergent by the reflected is 9 by 64 I by 3 by 4 into I. I and I get cancelled, so it will become 3 and 3 get cancelled, 4 and 16, so 3 by 16 is the answer. Getting different answers each time. I don't know. Okay, I'm trying once again, guys. Last chance. Okay, last chance. I'm sorry. So you have the incident ray, and that's going to get refracted here and reflected here. The reflected right with a question. So you know that only 25% of the incident energy is reflected, which is 1/4. So it's I by 4 because this is I. Now, therefore, you know 3 by 4th of I is getting refracted here, and that's going to get reflected back here. The reflection process, it was only reflecting only 1/4 of that, so it's 3 by 16 of I is getting reflected. On this space there's refraction happening, and you know 75%, which is 3 by 4 of 3 by 16, which is 9 by 64 of I. Okay, till here it's correct only. The ratio of this to this is what they are asking. 9 by 64 I by I by 4. So I and I get cancelled. This is going to go numerator. It's 9 by 16. Now I got the answer. 9 by 16. Sorry guys. So that's the 9 by 16 is the answer. You can slightly fast forward and learn it. So 9 by 64 is the answer. It's ratio of I2 by I1. That is this ray by this ray. Correct? Intensity. So calculate the ratio of I max by I minimum. So you know this is I1 by I2, what is it? 9 by 64. And I max by I minimum, which is also equal to B square by A square, because I2 stands for amplitude B and I1 stands for. So therefore B by A itself is 3 by 8. So I max by I minimum formula is A plus B the whole square by A minus B the whole square, as you should take B square out. So A by B plus 1 the whole square by A by B minus 1 the whole square. But what is given is B by A. So what you do is you write 8 by 3 plus 1 the whole square by 8 by 3 minus 1 the whole square. It is 11 by 3 the whole square by 5 by 3 the whole square, which is whole square. 121 by 25 is what I get. What did I do? I2 by I1. But why should okay? From here, see, why should I even equate it to this A square and B square? This is not a sum with regard to interference. Yeah, it is interfering, but it's not what to say. Okay, there's nothing wrong in what I'm doing. But why am I changing the amplitudes as A's and B's? Is that given that they have slightly different amplitudes? So yeah, it must be right only. Okay. So what I'm saying is I got I2 by I1. So I'm writing it as B square by A square. So B by A is 3 by 8. Yeah, 3 by 8. 3 by 8. A plus B the whole square by A minus B the whole square. So 3 by 8 has to become 8 by 3 plus 1, sorry. Which is 11 by 3 the whole square and 5 by 3 the whole square. That's not how they have done. I'll tell you how. Why we'll explore why the answer is different. I maximum by I minimum, they're not using this amplitude itself, they're just doing it with I1 and I2, and they're just writing it as but we should still get the same answers, what I'm trying to think. I max by I minimum according to me is A plus B the whole square by A minus B the whole square. This itself is actually B square by A square. So the B by A itself is 3 by 8. 3 by 8. Oh, this is not 64, it's 16. 9 by 16. So then it's 3 by 4. Whatever I'm doing is right only. Let's take B square out and B square out. You get A by B plus 1 the whole square by A by B minus 1 the whole square. Where A by B is reciprocal of this, so we'll write 4 by 3 plus 1 the whole square by 4 by 3 minus 1 the whole square. So it's 7 the whole square, 49, and 49 is to 1. Okay, that's the answer. Okay, I'm sorry guys, I made some when I copied it as 64. It is 9 by 16. When I cancel it, you get the final intensity to be 9 by 16. I copied it as 9 by 64. That was the issue. Let's go to next sum. So fifth question. So a ray of light with intensity I is incident on a pale glass slab. Oh, I finished with that sum, right? Let's go to next. The two slits, which is the fifth sum, the two slits are separated by a distance of 5 into 10 to the power minus 3 meters. An interference pattern is formed on the screen placed at a distance of capital D is equal to 1 meter. The separation between the two minimas, which means the fringe width itself is 0.1092 millimeter. Because in interference it's all uniformly spaced. So what is calculate lambda? Beta is equal to lambda into capital D by small d. Hence you can calculate what is lambda. It's beta into small d by capital D. Just substitute to get the answer. Can I go to next sum? The two monochromatic sources whose intensities are in the ratio I1 by I2 is in the ratio 81 is to 1, and immediately I'll write as A square by B square, which is A by B is equal to 9 is to 1. Produce interference. Calculate the ratio of intensity maxima. Intensity I max by I minimum. I'll do it as A plus B the whole square by A minus B the whole square. And you can take B square out and B square out and cancel it. So it will become A by B plus 1 the whole square by A by B minus 1 the whole square. 9 by 1 plus 1 the whole square by 9 by 1 minus 1 the whole square, which is 10 the whole square, and 10 the whole square is 100. This is 8 the whole square, 64, and so this will be cancelling with that itself is I max. That we just cancel it, and it will be 50 by 32 or a 25 by 16. What is my answer here? What have they given here? 25 by 16. So it's done. Okay, so let's go to 7th question. You see, repeatedly I've been using this for the maximum intensity. You have to learn it. In Young's double slit experiment, distance between the slits small d is given to be 0.001 meter, and the screen is placed a distance of 1 meter away. Okay, and no, 3 meters away. 3 meters away from the slit. The separation between the first and the 10th dark fringe The first and the 10th, the distance between the first and the 10th dark fringe. Is it interference? Young's double slit experiment, separation between the first and the 10th dark fringe. So the formula for the first dark fringe, 10th dark fringe, y 10th dark minus 5 first dark. Okay, it's 2 dark fringe formula is 2n minus 1 by 2 into lambda into capital D by small d. Substitute n is equal to 10, 20, 19 by 2 into lambda into capital D by small d minus first dark fringe is 1 by 2 into lambda into capital D by small d. Lambda into capital D by small d can be taken out common, 19 by 2 minus 1 by 2. Lambda into capital D by small d is 18 by 2, which is 18 by 2 itself is 9. So you know lambda, has lambda been given? 5672 Armstrong. Calculate lambda, that's the answer. Next 0.01. The separation between the first, okay, separation has been given. Why? It's been the y2 minus y1 has been given separation to be 0.0, what is it? 0.0 001, no? Slit, no, that 3 meters away. The separation is 15.2 millimeter. 15.2 into 10 to the power minus 3 is equal to lambda into capital D by small d, capital D into small d, lambda into capital D by small d into 9. What is it? 19 minus 1 is 18, yeah, 9. So then you know capital D, you know small d, you know you can find lambda. Capital D you can replace it as 3, small d you can replace it as 0.00, whatever that one is, 0.001, with which you call to cross multiply and get the value of lambda. You make sure you check your answer. So I'm not doing the sum, it's very simple, but make sure you're checking the answer. Let's go to the next question, which is the 7th question. 8th question. In Young's double slit experiment, the slit width is 0.8 millimeter, which is 0.8 into 10 to the power minus 3 meters, is illuminated by a source of wavelength 5873 Armstrong. Calculate the distance of the screen from the slit. Capital D is what they are asking you to find. Calculate the distance of the screen from the slit. The distance of the 5th bright fringe is 7.365. 7.365. Distance of the 5th bright fringe is 5 into lambda into capital D by small d. This paper is pretty easy, but for the one sum where I struggled because of calculation mistake, otherwise it's not at all a struggle. This paper is pretty easy. I would call this as level 1 and the other paper as level 2 rather. Okay, so calculate the so with this you know that this distance, you know lambda, you know small d, and you can find what is capital D. Just substitute and cross multiply. I'm not going to do the sum. The bandwidth of the entire apparatus, if the entire apparatus is immersed in the water, the entire apparatus is going to be immersed in water. So thus you get this wavelength. When you cross multiply, you get it as 5672 Armstrong. You make sure you get this answer. Now you immerse the entire apparatus in water. You know when you the wavelength would vary in water, correct? So what is going to happen? You know the refractive index of water has been given. Yeah, 1.33, and the refractive index is equal to wavelength in vacuum by wavelength in the medium. Wavelength in vacuum is something that's been given already. You just found it. Did you find that, or it's given? Yeah, you found only. Calculate the wavelength. Which sum am I doing? I'm doing the 8th sum, where the wavelength was already given. The wavelength was already given. I had to find capital D in the first part. Okay, you find the capital D in the first part. You get it as 1 meter. Okay, that's what it is. You substitute and see. You have to get it as 1 meter. I'm sorry. After that, you have to find the wavelength in the medium, which is wavelength in vacuum by refractive index. You know, wavelength in vacuum is the wavelength that's been given, which is 5873 into 10 to the power minus 10 by 1.33, and divide it, you will get the wavelength in wavelength in water. Once you get the wavelength in water, you have to find the bandwidth when the apparatus is B dash when it is immersed in water, which is lambda in the medium into capital D by small d. You already know capital D's value, small d's value. That term is not going to change. Only the wavelength in the medium changes. Substitute it here. Get the value of beta dash. Make sure you're getting the book back, the answer that they've asked you to find out. So let's go to next question, the 9th question. In Young's double slit experiment, a source of wavelength 5000, I think that must be Armstrong, is used for which the fringe width beta is 0.6 centimeter, which is 6 10 to the power minus 2 meter. The distance between the screen and the slit is reduced to half. The d is going to become d by 2. What should be the wavelength to get the fringe width of 0.003 meters wide? So you're reducing it, but what should be the wavelength? So the wavelength is going to change, but not to get the fringe width. The initial fringe width is this. The beta dash has been given to be what should 0.003. This is a new beta dash when it's d by 2. What should be the wavelength for this? Okay, so you know that initially using the first data, you know beta is equal to lambda into capital D by small d. Beta itself is 0.6 into 10 to the power minus 2 is equal to lambda is 5000 into 10 to the power minus 10 into capital D by small d. With this you can find what capital D by small d is, or small d has been given. Lambda's fringe width is given. If the distance between the slit reduced to half, what should be the wavelength? Okay, so with this you find what is capital D by small d, which itself is of the value 0.6 into 10 to the power minus 2 by 5000 into 10 to the power minus 10. You calculate this value and keep it. Okay, now take the second case where the beta dash, which is 0.003, is equal to lambda dash, you don't know what is the wavelength, but capital D by small d. And you know capital D by small d's value can be plugged in here. You can copy it, and hence you can find the lambda dash, and hence you can find the new wavelength. I'm not going to find it. You have to plug it in and find the answer, and should tally with whatever answer has been given. Let's go to 10th question. In Young's double slit experiment, the slit R small d is equal to 0.03 centimeter 10 to the power minus 2 meter, and the screen capital D is 1.4 meters away. The distance between the central fringe and the fourth bright fringe and the fourth bright fringe is 1 centimeter. Central bright fringe. So central fringe means central bright fringe, and that is from the center. We can take it as from the center to the fourth bright fringe. That distance itself is 4 into lambda into capital D by small d. That itself is given to be 1 centimeter, 1 into 10 to the power minus 2 meter. So find the lambda. So you know 4 is given, lambda you don't know, capital D is 1.4 into meter only, 1.4 sorry, by this 0.03 into 10 to the power minus 2 is equal to 1 into 10 to the power minus 2 meter. So with this you have to find lambda. Let's see if you're getting the answer. Let me continue with the sum. So this is 1.4, is it? 14 fours are 14 fours are 4 fours are 16, 4 are 4, 56. So it's 5.6 lambda by, okay, is equal to 1 into 10 to the power minus 2 is just 10 to the power minus 2. When you cross multiply, you can 10 to the power minus 4 into 0.03. So lambda itself is 0.03 into 10 to the power minus 4 by 5.6. Okay, and multiplying numerator with 100, it will become 3 by, multiplying the denominator also with 100, it will become 560 into 10 to the power minus 4. I don't know, I'm just, the answer here, it seems is 5000, and I don't think I'm getting anywhere near it. 56 5s are 6 5s are 30, 5 is 2 8. I'm not going to get the answer. What is the mistake with this sum again? Okay, sorry guys. What I'll do is I'll put a pass and then do it and then get the answer and then connect you up. Okay, now I understood my mistake. Okay, I very clear. Look at this. They say you from the central fringe. For the central fringe, n is not equal to 1. Okay, so you whatever if they've given you, and this is a 10th question. The central fringe and the fourth bright fringe, the distance of the fourth fringe itself